Hi guys, so this is the last video for this week. If you haven't seen the last one yet, again, I'm wearing this makeup because I'm doing a skeleton lesson in forensics and I'm just trying to get my videos out of the way. So we are doing Lewis dot structures for covalent molecules. So all of ionic is pretty simple or metallic is pretty simple, but covalent actually has some pretty complicated structures. So we kind of spend all of our time on how to draw the Lewis dot structures for them. The three that I'm about to show you are answers in your worksheet. You only have to draw 6 yourself, and I'm doing 3 of them for you now. So that means you only have to do 3. Okay? So please watch all the way through, learn how to do it, as well as get the correct answers for the 3 I'm giving you. All right, so first off, there is a simple set of rules. I wrote the rules over here. I'm going to walk us through each how to use them in these 3 problems. Again, these 3 problems are on your worksheet. So you have to use these rules to create the right shape. We're talking about the shape of the molecule here. I'm going to talk about how we get to these shapes in a second, but like literally, what is that molecular shape? How could I possibly know what it would make? Is by following these rules. Okay, the first rule is you take your compound, and it says on number 1 to count the valence electrons. Okay, so how do I count the valence electrons? I realize it's like really creepy that all you can see is my mouth with lines, but we're gonna have to deal with it. Okay, so you count the valence electrons for everything in the compound. How do I know valence electrons? I put this periodic table above your worksheet and in your resources. So this is the periodic table that has the valence electrons labeled. They're at the top. The numbers that are at the top is where it tells you the valence electrons. So let's find selenium, because that's what this one is. Se is selenium. So selenium's right here. Well, what column is it under? It's under 6. So it has 6 valence electrons. 6 electrons in its outermost energy shell. So I'm going to put 6 there. Okay, next, Br. Okay, so Br is right here. So that's bromine, and it's in the 7th column. So there's 7 valence electrons that it has. But there's 6 bromines. See how it says SeBr6? There's 6 of those bromines. So it's really a 7 times 6. I'm writing with my left hand. This is difficult. Okay, there we go. So now I need to add all those up to count my valence electrons. So 7 times 6. Max, what is 7 times 6?
That would be
7 times 5 is 35. Add 7, 42.
Yes.
Okay. So 42 plus the 6. So 42 plus 6 is 48. So we have 48 total electrons. I'm not going to be able to keep writing them with my left hand. That will not work. Okay, so we have 48 total electrons that have to be used in this picture. They have to be used, all 48. Okay. Now, the next rule says the element you have one of goes in the middle. And then you just bond all of the other atoms that are there to it. So I have 1 selenium and 6 bromine. So the element I have one of goes in the middle. So I put Se in the middle, and then I just bond everything else to it. I have 6 bromines. So 1, 2, 3, 4, 5, 6. And I'm going to put those bromines around it. Br, 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 like that. Okay? Now, the second part of that rule says to subtract the electrons that I've used. And I use 2 electrons every time I draw a bond. So I've used 2, 4, 6, 8, 10, 12. I've used 12 electrons. So I'm going to put my little electron count over here. I started with 48. I need to subtract 12. And I'm going to end up with 6 there and 3 there. So I have 36 electrons left. So what's my next rule? My next rule says the leftover electrons go on the outer element. So the outer elements are these bromines. I'm going to kind of erase this. It's kind of in the way. There we go. So I'm going to put them on the outer elements until they have 8. Because if you remember from last week, our magic number is 8 electrons. So how I'm going to do that is you put 1, 2, 3, 4, 5, 6. Remember, each bond counts for 2. So it already has 2 electrons here. 2, 3, 4, 5, 6, 7, 8. So that bromine has 8, like it's supposed to. I've used 6 of my 36 electrons, and I'm just going to fill the rest up and count them in a second. So fill them up. They each need 6 more because they already had 2, and that would make them have 8. Now let's make sure I didn't use too many. So I already used that much. I had 36 left. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I've used all of them perfectly. I've used all of my electrons up. Great. So now I'm going to go to my next rule. So my next rule says, any electrons left go on the center atom. Well, I don't have any electrons left, so I'm going to skip that rule and go to number 5. Number 5 says, check. Do all atoms have 8 electrons? If not, we have to double or triple bond. So let's make sure. Well, each bromine has 6 plus the bond, so that's 8. So all bromines are happy. The selenium in the middle actually has 2, 4, 6, 8, 10, 12. It actually has 12. It actually has too many. But that's what this little disclaimer at the bottom says. It says non-metals past phosphorus can actually hold more than 8. So if your thing in the middle has more than 8 electrons, so more than 4 bonds, it's okay. All right? So this one's actually good to go. So that is the molecular form. Here's my Max. Max, come here. All right. So Max has helped me make these molecules to show you. So Max, show him this one is actually this green one here.
This one is...
There you go.
Man, I can't remember the name.
Max, it's right there.
Octahedral.
Octahedral.
Hedral.
See, we're learning.
I can't pronounce stuff.
Okay, so it's octahedral is what this molecule is called. So you can see that it has those 6 bromines. Well, obviously in real life it wouldn't be flat like this. So in real life, those 6 bromines are the green little atoms, and the selenium is the silver one in the middle. And that atom would look like this. So floating around in life, here it goes. Here's selenium hexabromide. All right. So now we're gonna do the next one. Hopefully we can go a little faster now. So same thing, I start with rule number 1. Element you have, no I lied. Element number, it's always count valence electrons. I skipped it, can't skip it. That's what like this all depends on. So hydrogen is in the first column, so it has 1, but there's 2 hydrogens, it's H2. So that's gonna be 2 electrons coming from hydrogen. Selenium, we already found out earlier in the last problem, had 6. So it's going to be 2 plus 6, which is 8 valence electrons. So this one has way less. Our last one had 48 to start. This one only has 8. And all I can use is 8. So same thing, my next rule over here says the element I have 1 of goes in the middle. So the element I have 1 of, it's H2SE. So Se is again the thing that goes in the middle. So Se, bond to my 2 hydrogens. Like that. Okay, so I bond it to my 2 hydrogens. Then, little disclaimer below it says, subtract the electrons that I've used. So each bond is worth 2. So this is 1, 2, 3, 4. I've used 4 of my electrons. So I had 8, I've used 4, so I only have 4 left. So 8 minus 4, I only have 4 to use left. That's all I have left. Okay, so my next rule says leftover electrons. Oh, I haven't done that one. So bond, where did it go? Yes, leftover electrons go on the outer elements till they have 8. Okay, but then right here, this is very important, it says except hydrogen. These are hydrogens that are my outer elements. They never get any more atoms. Hydrogen is a really, really tiny element. It can only hold 2. It's done. I cannot give it any more. So I'm actually going to disregard rule number 3 because it says except hydrogen. So skip it. Any electrons left over, so now I'm on rule number 4, any electrons left over go on the center atom. Okay, I still do have those 4 left. I still have 4 left. I can't put them on hydrogen, so they have to go on the center atom. So they would go like this. Doot, 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 doot. There we go. I had 1, 2, 3, 4. 4 electrons left. Okay. Now my next, so that's it. I've used my 4. I've used all my electrons. I can put no more on there. My next rule says check, do all atoms have 8 electrons, except for we know not hydrogen, it's an exception, but does selenium have 8? 1, 2, 3, 4, because every bond has 2. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, selenium has 8. Hydrogen is an exception. So we're done. This one's good to go. Okay, so that is what its picture would look like. Those 2 dots up and down with hydrogen on the side. Max, you want to show them what it looks like?
This one is called bent
Yes.
because it's bent.
So if you get a little closer so I can see how it's bent, this is actually what a water molecule looks like. It's bent like this. So it would have been straight, so like the white hydrogens sticking out straight from the silver one. But see these lone pairs, these little weird flappy things at the top, they're supposed to represent, they represent what we call lone pairs, which means they're alone pairs of electrons we had left over that we just had to stick on the middle. So we just had to stick them on the middle, and they repel the hydrogens. They push the hydrogens down, so now instead of being a straight molecule, it's bent. All right, last one. So the last one is CS2. So carbon and sulfur, there's 2 carbons. So my first rule is count electrons. Carbon is in the 4th column on that periodic table, so it has 4. Sulfur is in the 6th column, so it is 6, but there's 2 of them. So 6 plus 6 is 12. So I add that up. 4 plus 12 is I have 16 total electrons that I have to use completely all up. Okay, 16 total electrons. Now my next rule says the element that I have 1 of goes in the middle, bond everything else to it, and then subtract the electrons I've used in the bonds. So I'm going to put carbon in the middle, bond it to sulfur. There we go, there we go. And then I've used 1, 2, 3, 4. I've used 4 of my 16, so minus 4. I have 12 electrons left to use. Okay. 12 left to use. So rule number 3 says leftover electrons go on the outer elements until they have 8, except for hydrogen. But these aren't hydrogen, these are sulfurs, so I need to fill them up till they have 8 to make them stable. So with my 12 remaining electrons, 1, 2, 3, 4, 5, 6, that's all I can put on sulfur because it already has that bond of 2. So 2, 4, 6, 8, it's done now. So I've used 6 of my 12. Boop, and I have 6 left, which is exactly how many I have for the other sulfur. 1, 2, 3, 4, 5, 6, and the bond gives it 7, 8. So I've used up all my electrons, they're done. Can't put any more in the picture. But this is something we haven't seen before, so we have to go to rule number, we're actually going to skip number 4, we'll go to number 5. So number 4 says any remaining electrons go in the center. I don't have any electrons remaining, so skip 4. Number 5 says check, do all atoms have 8? If they don't, then you have to make double or triple bonds. So sulfurs have 8 because they have 1, 2, 3, 4, 5, 6, and the bond makes 7, 8, and they each have that, so they're good. But carbon, how much does carbon have? It has 1, 2 right here because it has that same bond. 3, 4. It only has 4. It has 4 electrons. It's supposed to have 8. So this is something that you can see in your notes in more detail, but it's called a double bond. It needs, so if it only has 1, 2, 3, 4, it needs 4 more. So I'm going to steal electrons from sulfur and make him share double. So now they're going to have a double bond with each other. That makes carbon have 1, 2, 3, 4, 5, 6. Still not happy. So he's going to steal from the other carbon and make him share those electrons as well. So now if I erase where I stole, so you can see the double bonds like that. Now sulfur has 2, 4, 6, 8, so sulfur's good. Carbon has 1, 2, 3, 4, 5, 6, 7, 8, and this sulfur has 2, 4, 6, 8. So everybody's happy now, everybody has 8, but they needed those double bonds. So Max, let's see those double bond.
This one is called linear.
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 Linear, like a line. So show them how it's like in a line. There you go. So see how it's flat? So this one is a lot like the last one I just showed you that was bent. So see, they both have an atom in the middle and 2 on the outside, atom in the middle, 2 on the outside. But the difference is this one has no lone pairs. And this one does have those dots in the center atom. The dots, or the electrons, is what they actually are in the center atom, repel these elements and push them down, make them bent. These, without the lone pairs, just make a straight line. Straight line molecule. All right, guys. Woo! Remember, those were 3 of your actual answers. Go use them.